So 11.6 number 70 is a class of thing we haven't talked about yet. They're asking you to verify that this equality is true. You guys see that? So we've got e to this whole mess of log of x over 2, and supposedly that's the square root of x. You guys see that? So really what they're saying is, hey, we're wondering if this is true, could you go check it for us, right? That's cool, that? So to start this, you start with one side. Like, for instance, I'm going to start with the e to the log of x over 2. I recommend that you start with the more complicated side. It's usually easier than, this way I can deconstruct instead of having to create. So,
Do you want to like natural log of x minus natural log of 2?
okay.
First before you simplify.
So that's not a half bad idea, except that they mean to take all of log x and divide by 2. You guys see that? I'm not taking the log of x over 2. I'm taking the log of x and dividing by 2.
Oh,
But you just
oh.
So let me rewrite as this is e to the log of x over 2.
Yeah.
Does that make things clearer? Yeah?
And we can put it in exponential form, so we can see.
Don't do that. Easier.
Cancel out the natural log.
Maybe even easier. What if I wrote this? Is this the same thing? If I write e to the 1/2 times natural log? You guys see that's the same? And now maybe you see a power or a log rule that you can fiddle with? How about this one?
actually the 1/2 is.
Oh.
I have a rule that lets me take powers down to the front of a logarithm, right? Is there anything stopping me from using that to bring the power up?
No.
No. So that's what I'm going to do with this. I'm going to bring the power up, and I'm going to get e to the what?
Natural log of x. Or no.
Natural log of
Square root
square root
of x.
of x.
Oh, okay, and then natural log.
And then the e and the log
Cancel.
undo one another, right? So I'll get square root of x. You guys see that?
Yes.
So check done. Should we try another one of these?
Yeah.
Okay, let's try number 71 quick because we're kind of standing here. So what's 71?
Log 60 of x. Log base 10 60 of x. Right. I'll just take it.
I do want to just take it. Okay, so I'm going to write symbols and then we're going to talk about how to read them. Okay, so can somebody tell me how to read this thing? So log base 10 of
60 to the x
60 to the x, good,
minus log base 10
minus log base 10 of
6 to the x
6 to the x
equals x is x.
is x,
X.
right? That's a question. You guys see that? Because we're wondering, right? We're trying to verify if this is true. So, do you guys see a log rule that you could use to stick two things together here?
Subtraction and the exponential.
Yeah, this subtraction corresponds to division, right? So, I'll get log of what?
60 to the x.
60 to the x over 6 to the x. Right? So that's just this piece, and I did a log rule. Yeah, so we can say, okay, this is log of 60 over 6 to the x. So that's kind of undistributing an exponent. And then what's 60 over 6? 10. So I'm going to get log of 10 to the x. What's the answer to this question? How about what's the question that this thing's asking?
It's asking what power of 10 is this thing?
Yeah, so this guy's asking what power of 10 is 10 to the x? The answer to that question is x. Oops, exposed. This is log and 10 to this stuff cancel. Really? Right, they undo one another. So I get x. So
X equals X.
yes, indeed, this is true.
Could you do the log rule where you take the x out, it's the exponent in front?
Yeah, that'd be a good idea too. You guys see that? So instead of thinking about what power is this, I could just take the x down and then notice that log base 10 of 10 is 1. Yeah, that would be cool. Other things? Questions? These verify ones are some of the hardest because you have to be a little bit creative with the log rules to get them to work. So my advice is try stuff that seems valid until it works, I guess. Other things? Okay.